Welcome back to the Deep Dive. Today, we're really diving deep into something pretty mind-bending. We're exploring other dimensions, alternative universes,
Yeah.
and we've got some fascinating sources lined up, a YouTube discussion on AI and string theory, and this really compelling pitch for a new kind of, well, they call it a diagnostic engine. So the big question for this deep dive is, how are we actually trying to explore realities beyond our own? What are the different ways people are tackling this? We're going to look at two main methods. First, there's what we're calling speculative simulation using AI and supercomputers. And then there's this, frankly, revolutionary idea, the reality level analyzer. And you'll see pretty quickly, just figuring out what could be out there is incredibly difficult.
It really is. And exploring these ideas, it's not just, abstract theory for the sake of it. It's fundamental. It helps us understand the very nature of our universe. So this dive, it's about what we're exploring, sure, but maybe more importantly, how these two approaches are just fundamentally different in what they try to do and what they might tell us.
Okay, so let's start with the science bit, the big hurdle. When you talk about extra dimensions, especially in things like string theory, the problem is trying to solve Einstein's equations for these, 6 extra compact dimension.
The ones curled up really small.
Right. And the kicker is there aren't any simple analytic solutions. You can't just, write down a neat equation.
Exactly. And why are they so hard? Because they're nonlinear. That's the key term here. It means gravity, sort of back reacts. It talks to itself in complex ways. It's not like simpler equations where you can just add two known solutions together to get a third one. Here, you change one tiny thing. You basically have to start over every time. It's incredibly complex computationally.
Right. You can't just piece things together easily. So traditionally, how did scientists even try to deal with this? They used massive numeric simulations, right, on these huge supercomputer clusters.
Yeah, that was the only way.
And the source mentioned it could take months to get results. Just months.
Months. Which, drastically limited the kinds of questions you could even realistically ask. It was a major bottleneck.
And that really sets the stage perfectly for this first method we want to discuss, speculative simulation. Okay, so this is where things get really interesting with AI. Given those huge computation times, how did AI change the landscape here?
Well, it's been a genuine revolution for theoretical physics. Machine learning algorithms, they can now numerically solve these really intricate differential equations much, much faster.
Faster is good.
Oh, definitely. But what's fascinating is how it's not like AI learning from photos, right? Or even learning from a giant database of existing solutions, because for these specific problems, we often don't have that database.
Right. No easy answers to learn from.
Exactly. So instead, it uses the actual framework of these neural networks to try and solve really complicated equations directly. It's using the AI structure itself as the solving tool.
Wow. Okay. So the impact, pretty immediate, I guess.
Absolutely. The source says these techniques speed up a lot of computations in a really substantive way. We're talking orders of magnitude faster.
And that speed up made new things possible.
Yes. The StarTalk Plus discussion highlighted a major breakthrough. It allowed groups to compute quark masses in string theory for the first time.
Quark masses, that sounds huge. Like fundamental properties of matter.
It is huge, theoretically, but, and this is a really important but, these are not the quark mass values that we actually observe in nature.
Okay, so it's not like they plugged in our universe and got our quark masses.
Not exactly. It's more like if you just hand me some extra dimensions, some theoretical geometry, whatever they may be, and then say, what would the quarks look like in that universe? Now we can actually calculate those numbers. It's exploring the possibilities.
Gotcha. So it's a way to test hypothetical universes described by string theory.
Precisely. It's a perfect example of simulate alternative dimensions and observe what could be. You build a model, run the numbers, see what physics emerges.
Okay, so let's sum up this first approach then. We're calling it speculative simulation. It uses AI, computational power, based on the physics we know, the scalar metrics of our universe.
Things like constants, known laws.
To explore these theoretical possibilities, compare factors in potential universes, it's modeling what if. All right, now brace yourself, because we're about to take a pretty sharp turn. We're moving from simulation, which is grounded in computation and known physics, albeit exploring the unknown, to something called the reality level analyzer, pitched by a Dr. Melvin Sewell. And the key thing, it's explicitly described as not a simulation, it's a diagnostic engine.
Yeah, the language itself signals a major shift. Diagnostic engine. It sounds almost medical, but for reality itself. And the core difference they claim is profound. Simulations, as we said, they approximate dimensions by sort of scaling known physical constants. They work from our physics outwards. The analyzer, though, supposedly leverages resonance-based input to scan, interpret, and interact with multiversal domains in real time.
Resonance-based input, not scalar metrics.
Right. It suggests something vibrational, maybe energetic, not our standard physical measurements, and real-time interaction. That's a huge claim compared to running a simulation.
The source actually lays out a direct comparison, which I think is really helpful here. Let's walk through it. Okay, first, input parameters, speculative simulation, scalar metrics of our universe, our physics, reality level analyzer, resonance parameters, something else, energetic signatures maybe.
A completely different starting point, yeah.
Next, function. What does it do? Simulation. Aligns computational models. Simulates alternative dimensions. Compares factors in potential universes. It builds and tests theories. Analyzer. Scans and diagnoses domains. Analyzes blind spots and tier progression. Maps and interacts with multiversal zones. That sounds much more active. Navigational almost.
Definitely implies active engagement, not just passive observation or calculation.
Okay, then outcome feedback. Simulation lets you observe what could be. You see the results of the model.
Theoretical possibilities.
The analyzer promises to activate real-time, reality-aware feedback, like getting live data from these other domains.
Which is, I mean, that's an extraordinary claim, reality-aware feedback.
And finally, the methodology. Simulation is theoretical modeling. It's bound by or limited to physical constants as we currently understand them.
Right, grounded in known physics, even when extrapolating.
The analyzer, described as experiential diagnostics. And get this, it supposedly traverses conceptual, emotional, paradoxical terrain.
Okay, now we're really moving beyond standard physics, aren't we? Conceptual, emotional, paradoxical terrain. That's not typically the domain of physics equations.
Exactly. It suggests operating on fundamentally different levels of reality.
And the document expands on this why it matters aspect. The experiential diagnostics part claims to provide reality-aware readings based on energetic conditions in real time. Again, moving beyond pure theory. Then there's metaphysical engineering. The idea it operates across conceptual, emotional, and paradoxical terrains. This implies, well, engineering reality on levels that aren't just physical matter and energy as we usually think of them.
Metaphysical engineering.
Wow.
And finally, applied cosmology and sovereignty. This suggests it allows users to, and I'm quoting here, not just to speculate, but to embody, traverse, and recalibrate within multiversal structures.
Embody, traverse. That's suggesting direct personal interaction and agency within these other realities.
It's a complete paradigm shift from running simulations on a computer.
And connecting this back to the string theory stuff we talked about earlier, the analyzer's supposed activation potential apparently includes mapping compactified dimensions, those tiny curled up ones, chaotic fold zones, and invisible dominions. And again, real-time feedback for strategic engagement. So instead of just calculating properties of those compact dimensions, it's claiming a way to potentially map and interact with them directly. A navigable multiverse, not just a theoretical one.
It really paints a picture of a much more dynamic, accessible structure to reality, doesn't it?
It certainly presents that possibility, yes. And this whole discussion brings up broader implications. Touching on what the first source called new physics. That's the search for physics beyond our current standard model. You know, could there be more than the four fundamental forces, maybe a fifth force we haven't found?
Like dark matter interactions or something.
Potentially, yeah. Or understanding dark energy and dark matter themselves, these huge components of the universe we can't directly see. Or even tackling things like black hole singularities, those points of infinite density that current physics struggles with. String theory aims to repair them by suggesting they're not points, but tiny vibrating strings.
And AI simulations could help explore those ideas.
Exactly. And they could also explore concepts like duality in string theory. That's the fascinating idea where two different theories or two different geometries look totally different, but they're actually mathematically equivalent, like different sides of the same coin.
So it simplifies the search space.
Yeah.
Fewer unique possibilities to check.
Precisely. It's a powerful theoretical tool. And briefly, there's also supersymmetry, mentioned in the source. The idea that known particles have heavier additional partners. These partners would be much heavier, and the symmetry spontaneously broken in our universe, which is why we don't see them easily. Simulations help explore if these ideas hold water.
So, thinking about the future, it's kind of wild to have these two paths laid out. You've got speculative simulation, pushing computational boundaries, exploring what could be based on theory.
Grounded in math and physics, powered by AI.
And then you have the reality-level analyzer, making these extraordinary claims about real-time diagnosis and interaction, navigating what is across, well, conceptual and emotional terrains, too.
Yeah.
It really makes you pause and think, what would it actually mean to navigate cosmology? Not just observe it, but engage with it. That's a fundamentally different relationship with the cosmos.
A completely different posture, yeah.
So wrapping up this deep dive, it's been quite a journey. We've looked at these two really distinct ways of exploring beyond our immediate reality. There's the computational might of AI driving speculative simulations, calculating the properties of theoretical universes faster than ever before.
Building those intricate models, testing the boundaries of known physics, exploring the what-ifs. And then, yeah, there's the reality-level analyzer, a truly bold, maybe even radical concept, proposed not as a modeler, but as this diagnostic engine for real-time, resonance-based interaction with the multiverse. It's suggesting a direct experiential path.
So whether it's through incredibly sophisticated computation or these proposed, maybe paradigm-shifting resonance-based diagnostics, it feels like the quest to understand the full scope of reality, maybe even interact with it, is definitely accelerating. It's moving from pure calculation towards, well, potential navigation.
The frontiers are certainly being pushed from very different angles.
And that leaves us and you with a final thought to chew on. As we develop tools, whether they simulate or claim to diagnose and traverse, how might our actual definition of reality start to expand? And if we could genuinely engage with these other domains, these multiversal structures, what new responsibilities might come along with that ability?
Yeah, that's the big question, isn't it? What happens next?